Okay guys, this is our lesson 5.2, graphing polynomial functions. I'm going to try to keep it short, so pause when you need to take notes. Remember roots, that's the same things as our x-intercepts. So when we're looking at a graph, that's just anywhere it's going to touch or cross through the x-axis. A double root, so remember when we look at a double root, that's something when we talked about parabolas, a double root is where it just is going to touch the x-axis. An imaginary root is when we're not going to touch the x-axis at all. And then normal roots obviously just go through the x-axis. So just kind of keep that in mind. The biggest thing that you maybe need to remember is the difference between a double root, which is right here, right, when it touches and turns around, and then a regular root is just going to go through the x-axis. Okay, we have 6 different parent functions to talk about. You may want to watch this slide and then go back and draw what you need to. So y equals x, that's just our linear function, is going to look like that. Y equals x squared is our parabola. Y equals x to the third. These are the ones we just learned about where we had the reference points, the weird s. Some things to note about these. Well, actually, let me finish showing you what they all look like. On these others, I haven't really written what they look like, but if we have x to the fourth, something with x to the fourth might look like this, kind of like a weird W. I don't know why I wrote that. Something that looks like x to the fifth could look like this. And then x to the sixth. They're just going to get bigger and crazier. Let's see, x to the sixth. All right, so some things that I want you to note about these. Remember, pause if you need to, but some things that I want you to note. First of all, the degree that you see, and the degree, remember, is by the exponent. The exponent tells us how many roots. So if we go back and look through, this first one has 1 root, right? One place that it crosses through the x-axis. The next one, that looks like 1 root, but really that's a double root, so this is going to have 2 roots. Again, looks like 1, but that's really a triple root because this is x times x times x, right? That means that x equals 0 3 times. So that has 3 roots. And then if you look down here at the bottom at all of these, this has 4, 5, and 6 roots. 1, 2, 3, 4 on the x to the fourth. 1, 2, 3, a double root right there. So 1, 2, 3, 4, 5. And then x to the sixth, 1, 2, 3, 4, 5, 6. All right, take a second to make sense of that. Rewatch that little section if you need to. All right, and the only other thing that we need to notice is our end behavior. Remember, end behavior is what it does on the left side of the graph forever, and then what it does on the right side of the graph forever. So if we look, first of all, I want you to notice, right now I am circling all of the even functions. These that are even have even exponents. So just remember you're going to look at the exponent to determine if it's even or odd. Those with even exponents, look at those and think about what's the end behavior. On all of them, they're going up on both sides, to the left and the right. So it's going to be the same end behavior up both sides. So on even, we want to have the same end behavior. And if it's positive, that's going to be up on both sides. All right, if we look at odd, which are all the ones we have left, and you may say, how is that first one odd? Remember, x just has an exponent of 1. That's an odd number. So if we look at the ones that aren't circled here, those are my odd functions. And notice that they all have opposite end behavior. So like, might go down on one side and up on the other, right? The arrows here, like I'm looking at x to the fifth right here, these arrows are going in opposite directions. So that's something that you're going to notice with odd. And while we're still looking at this same kind of image, I want you to think about if we have negative coefficients, what does that do? So for example, y equals negative x squared, if it said negative x squared, remember that would mean it opens down. The end behavior still stays the same, so they're both the same direction. It's just now that they're both going down because it's negative. The same thing happens if I have y equals negative x to the third. I'm still going to have opposite end behavior, but instead of going like this right here is positive, instead now I'm going to be going negative. So this is, if you have a negative coefficient, now it's going to just be going down as you go to the right, but it's still having this opposite end behavior where one side is up and the other side is down. All right, so that's all we need to know to be able to do our example. We only have 2 examples, and the second one is just to give you one more chance to make sense of the first one. All right, so what they're going to do is give us a graph, or sorry, give us an equation and ask us to graph that. So there's some things that we need to note. First of all, this equation right here in this format tells us our roots. So if you look, the x to the third means we're going to have a root of some sort at 0. That x to the third, remember, is x times x times x. So we're actually going to have multiple roots at that same point. So it's going to look a little different than normal. This is going to give us a root of x equals 2. So we're going to cross through 2. So I'm going to go ahead and make those points on my graph. I've got 0 and 2. That's where my curve is going to cross through the x-axis, and it's the only places it's allowed to cross through. My negative here is going to flip my graph or reflect it over the x-axis. So some things that we need to take a note of. First of all, the degree right here, how many x's are in this equation? And you should count up and see it's 4. So this is even, which means it should be the same end behavior. And because it's negative, that means it should both be going down. So before I even draw what it looks like, I'm just going to draw arrows going down on both sides because I know that's what needs to happen with the ends. I know that I'm going to go through my x equals 2. Hopefully yours is drawn a little bit better than mine. And then to the third, that means at this root right here at 0, it should kind of look like that to the third power graph. So that means it's going to draw this weird little S. And somewhere up here, we don't really have to be specific, but somewhere up here, these are obviously going to have to meet. So I'm just going to loop those around so that it looks like that. So pause real quick if you need to and rewatch this to make sense of how I figured out the important parts of that graph. And the important parts are end behavior. Here, I'll even circle them so you can see them a little bit better. These ends are important. That's what I'm going to grade. And then how and where it crosses the x-axis. Those are the things that are the most important. The last little part that we need to take a note of is domain and range. Remember, domain are our x values. So if I look in the x direction, this is going to go out forever to the left and to the right. So my domain is just all real numbers. And my range, because I don't know the maximum value up here at the top, I don't know how high it actually goes. My range, I really just want you to kind of get in the habit of seeing what it's going to do here. So my range, I'm just going to make a note that it goes down forever. And when we get more specific, we'll actually do a better job of naming that range, but I just want you to recognize that behavior. All right, last example. So I'm going to do the same thing. The first thing I'm going to note is all my different roots. So if I look here, I'm going to have this root is going to be x equals -1, and it is a double root. I know that because it's got this exponent 2 up here. And the other one's going to be x equals 3. So I'm going to start by I'm going to mark x equals -1 and x equals 3. I know that's where it's going to have to cross through or at least touch the graph. The 2 out in the front literally means nothing. So the only other thing I have to consider is this odd or even? So what does that do with my end behavior? So I've got 2 x's. If we look, I've got 2 x's right here, right? That's to the squared. So 1, 2, and then a third one over here, which is going to give me x to the third. Because that's odd, I'm going to need opposite end behavior. And because this 2 in the front, the only thing that actually does tell me is that it's positive. So my end behavior is going to always be up at the end, and since it's opposite, that means it's going to have to be down on the front side. And so I'm going to go back and draw my arrows down and up. And it kind of looks funny, right? So this is going to cross here. And then because this is a double root at -1, remember double roots for polynomials, they touch and then turn right back around. So my double root here is going to touch and then just go right back down. It's not really even going to cross through because it's just a double root. So the things that we need to check real quick, make sure your end behavior is opposite directions, make sure these are your roots, and then domain is really always going to be all real numbers. And range, this time range, it doesn't even matter how high or low certain parts of the graph go because it's going to go up forever and down forever. So my range is also going to be all real numbers. Go back and rewatch these last two examples if you need to, because this is what we're going to be doing in class tomorrow. So I want to make sure that you feel like you've at least got the basics before we start some examples tomorrow.